C language has a inbuilt operators. Operators basically perform the operations on operands. We know that, right? Operators, which we use for actually manipulating the data and then variable content, right? So that is what I think today's topic. Welcome, guys. Thanks for joining. Welcome to Maths Bridge. We shall continue our C programming learning. Okay, we are actually part of a slogan called a train and learn. We train, you will get an opportunity to learn. Okay, without further delay, let's get started. Folks, please do visit us at our YouTube channel Maths Bridge. I'm sure I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. C program supports a rich set of built-in operators. So basically like C language. The operators are used in a program to manipulate data and variables. They usually form a part of mathematical or logical expressions. If you could see the classifications of the C operators, we have a arithmetic operator, relational operator, logical operator, assignment operators, increment and decrement operators, unary operators, conditional operators, it is called a ternary operator, bitwise, and then special operators. Let's see each one of them with sort of worked out problems. Let's have a quick review on C operators. When I say arithmetic operation, we know that, right? Addition, subtraction, multiplication, division, modulus, increment and decrement. You might see these symbols plus, minus, star, division, and ampersand is like a modulus operator, plus is like an increment, minus is a decrement operator. These are all part of your arithmetic operators. Okay, and you have an assignment operator, meaning equal means assignment, plus equal means add and assign, minus equal means like a subtract and assign, star equal means multiply and assign, division and assign is nothing but division. And so plus, minus, star, divided are the prefix for equal sign is nothing but a assignment operators. We have all these operations is doable, right? Now look at relational operators. It's a comparison. When I say relational, what that means is you are comparing between two elements in the expression and then stating out whether they are equal or unequal. The comparison always gives either the true or the false, right? We have a is equal, greater than or equal, less than or equal, not equal. Similarly, we have a logical operators. Logical operators means a logical and, logical in or, logical not. So logical operations, right? These are the symbols. Ampersand is kind of a logical and operation. Twice explanatory, right? This is like or operator. One means a not operator. All logical. When I say logical, it returns either true or false. Similarly, we have a bitwise operator. Bitwise means like one and in an or and exclusive or. So bitwise and, bitwise or, bitwise XOR. These are called bitwise operations. We do have like a conditional operators. Like this is like an if else then kind of, right? This is what ternary operator. Okay, this is also like C supports. Let's look at arithmetic operators. We have plus, minus, star, division and percentage, right? Plus means like adding two operands, right? Plus is an operator which operates on operands. We require two operands, right? A plus b, a minus b. Like subtract also same, like second operand, subtracts a second operand from the first operand is what it is, like num1 minus num2, right? Something like that. Multiplication again between the two operands, it multiplies both operands and produce the output. Division is also same, numerator divided by denominator, right? This is called a modulus operator. That means like the returns only the remainder. Okay, so these two are actually is a kind of like an important for us for solving certain problems. These are like a kind of a binary, sort of operands. We require two operands. There is, increment and decrement. These are called a unary operators. These are basically like an increasing by one. What are the variables that we do post increment and pre increment. So if you see that like worked out problem here, in this case I have a two numbers declared as an integer assigned each one of them like certain value. Here in the case 200 and 100. Now I'm trying to do like all arithmetic operations. In the first statement I'm just trying to add them, num1 plus num2. The return is actually you have a sum, right? The sum 200 plus 100 is like 300, right? So the output you can see here, addition operation gives 300 because adding of num1 num2. Subtract num1 minus num2, so you are subtracting 200 minus 100 remains 100. That's your resultant. Multiplication means like your 200 multiplied by 100. Two operands are multiplied together to produce the output, right? That's what your math operation. Division, otherwise a slice 200 by 100, it means like a 2. Modulus is like a reminder. So when I say 200 by 100, what would be the remainder? Because 100 times 2 is like a 200, so leftover is 0, and hence your modulus operation returns 0, right? So this is very important for us. So in addition with that, I also included like unary operators like an increment and decrement operator. Plus means like increased by 1, minus means like increased by twice. So if you see here, I did like plus 1, so 200 becomes 201, 100 becomes 101. Once I incremented, I am now decrementing back to original value. So this is how arithmetic operations are going to help you. I hope you are clear, right? It's much easy because day in day out we've been working on these problems, but now programmatically we're explaining with different dimension. Now let's look at assignment operator. We have a equal, right? Whenever you see that equal, that's called an assignment operator. So a simple assignment operator means assigning values from right side operand to the left side operand is called equal. What that means, like int inum equal to 10, inum equal 10. So right side is a 10, which we are actually assigning to inum. That's what equal means. So assignment operators we've been doing, we are working on so many sample programs where we are using them, but now you have to realize to say out loudly that okay, this is an assignment operator. Okay, plus equal, right? You have to add and then assign, right? This is what it means, add and assignment operator. It adds a right operand to the left operand and assign result to the left operand. That is how you have to read. Minus equal means subtract and assignment operator. What it means, right? It subtracts the right operand from left operand and assign the result to left operand. Okay, similarly multiplication and then division and modulus, right? Here is an example, you could see it, right? So if you could compile this code and then see the output, this is what the output would be. Clear? So if you see here line number 9, what you are doing is like a plus equal 10 means like if you can write it back, inum equal to inum plus 10. So inum value, the number is also previously assigned is 10, 10 plus 10 is 20. That is what you see, 20. So now I have inum is 20 minus 10, inum minus 10, right? So you can rewrite this as a inum equal to inum minus 10. Okay, inum equal to inum multiplied by 10. Inum equal to inum divided by 10 can also be written as inum division equal 10, right? This is what I think explanation already given here, self explanatory. You can just see it like now you can rewrite this statement as is, right? This is called as a assignment operators. Comparison operator, comparison are relational operators which is basically like a comparing two operands and then provides the result based on the comparison, either it is true or false, right? Equal double symbol, most of the times like we do have a mistake of giving like one equal as an assignment, but comparison requires two equal symbols. So check if the values of two operands are equal or not. If equal, returns true, otherwise false. Okay, not equal, this is checks if the value of two operands are equal or not equal. If not equal, right, this means not equal. If it's not equal, it returns true, otherwise false. So greater than, less than, greater than, equal to, less than or equal to, all these basically like giving a output as a logical return, which is true or false kind of thing. If you look at like in a worked problem, a sample program where I have a two numbers and then I'm trying to do this all relational operators to see what would be the output. 105, right? Number 100, number 2 holding like a 5. Now I'm comparing using comparison operators, right? So 100 equal to 5, is it true? This expression basically a false, and hence it returns false value 0. So logical, you can think of false means 0, 1 means true. So for example, second statement you see num1 is not equal to num2. So the expression is right? 100 is not equal to 5. So your statement is true, and hence this should return a logical value 1. Get it? So num1 is greater than num2. You agree? 100 is greater than 5. So this logical expression returns true. So something like that, you can always see how these comparison operators helps you to compare the two operands and return the result as a logical value. Either it can be 0 or 1, true or false. True means 1, false means 0. Here is the logical operator. So logical AND operator, logical OR operator, logical NOT operator. So logical AND means like the both operands non-zero value, then it returns true, otherwise false. Logical OR operator means any one of the logical expression is true, then overall expression becomes like a true, right? So non-zero operand is nothing but a true. That's anyway. Logical NOT operator means like it's like not. If it is the expression evaluated as a true, then not means like false. Right? That is how you see it. Negation of actual logical result. So if you could see the worked out problem, so I have two numbers. One is two are non-zero numbers of 10 and 5, right? If you look at that expression, what it returns is in num1, greater than 5, right? That is what it is. So what this comparison says, 10 greater than 5. So logically it's true only, no? So this evolution, outcome of this is basically true. Okay, make a note. Now look at the second one. Num2 less than 5. 5 less than 5 doesn't make sense, right? It's a false, right? So now I have a true and false. AND operator only returns true if the both are true. So in our cases, like this is true, this is false. True, false with AND operation returns false. So the output would be false. False means logical 0. So 0. Clear? Now look at the second example, OR operation. If the first expression evaluates 1, OR always becomes like 1. That's why you are no need to validate the second expression at all, because that is how the OR operation works. Any one expression is 1, then logically the output becomes 1. Right? That's called logical OR operator. Now negation is called a logical NOT operator. Whatever the expression that you evaluated, so if it is true, and then negation means like it false. If it is false, negation means it's true. So opposite, true means false, false means true. That is how it is. So num1 10 greater than 100. This is false, right? So false, you are operating not to the false, becomes true. You are flipping false becomes true. So true means logical 1, right? The 1 value. So this is how the logical operators works. These are essential for writing a program and then do certain loops, comparisons and all. Here is the bitwise operators. So it is a little tricky. This is a very important concept. The people who are working on embedded systems, they should know how this bitwise operator works. So far we are working on the whole numbers, a complete number, but now each number is a representation of a binary digits, right? So now we have to just understanding like now we are going to represent the binary operations on each value. Let's say I have a number called FF, 0xFF. This is a hexadecimal value. Hexadecimal value, right? If you can actually convert into binary, This is nothing but like all ones. This is what representation of XRFF means. If A means like a 10 10, right? 1 0 1 0 1 0 1 0. This is a binary conversion for this value. So these called bits. Now this bitwise operator operates on these bits, right? Like I said, like we have an AND operation, OR operation, exclusive OR operation. The thumb rule here is, in AND operation, if one of the input is 0, the output becomes a 0. Think about this truth table. 0 0. If you see 1 0, then output becomes 0. If you see 1 0, output becomes 0. At least 1 0. What I meant. If the both are 1, becomes 1. So logical 1 means logical 1. 0 means like logical 0, right? True and false kind of thing. So AND is a kind of a multiplier, right? 1 into 1 1, 1 into 0 0. That's short, right? If you think of that's an AND operation. So if you look at evaluate this AND operation here, 1 1 1 1 0, so multiply both becomes 0, 1 1 becomes 1, 1 0 0, 1 1 1, 1 0 0, 1 1 1, 1 0 0. So AND result is like this. Bitwise AND means 1. So 1 ampersand, if you see, that's a bitwise operator, AND operator, bitwise AND operator, but this is like a truth table. So each bit, how you are going to evaluate. Clear? Similarly, OR operation. OR operation means any one of the input is 1, then output becomes a 1. That means like if the both zeros, then output 0, otherwise 1. So look at now 1 1 output 1, OR operator, 1 0 output 1, because I have 1, at least 1 input 1, 1 1 becomes 1, 1 0, 1 plus 0 is 1, 1 plus 1 is also called as 1 because 1, 1 0 1, 1 0. So this is how your OR operation works. Clear? Excellent above. So you exclusive OR operation also there. There logically, if you can think of this, how this works is, XOR operator. XOR operator is basically like a not to the OR. That short. Whatever the output that you see, exclusive OR, right? This one, A bar A B bar plus A B bar, A bar B plus A B bar. That is how it generates. So okay, I'm leaving this option now, but you can still think and then practice more on it. All right. Not means what? So only one input. Whatever input you supply, if you supply true, that becomes false. If you supply false, it becomes true. Logical 0 become 1. 0 means like 1, 1 means like 0. That is how you predicting output from corresponding input. So let's look at one more sample program here. How the logical, bitwise operator basically works. Okay, so if you look at this worked out problem, I have three numbers, 15 10 5, and then if you can do like a bitwise operator by this math, then it produces the result. The result is like, you see, if you do like logical and bitwise operator for number 1 and number 2, 15 bitwise and with 10, it produces 10. But you have to convert these numbers into binary and then do math. Then you see that output and then convert back to this, decimal value. That is how you get the output. So you do like in a paper practice first, to see how these values are actually getting generated. Then that will understand. So we have one more topic that you can see is like a left shift and a right shift. When you do left shift, that means like you are multiply by 2 with that number, right? If I have 15, left shift by 1 means like 15 multiplied by 2 is called 30. Okay, if I have a 10, right shift means like divided. So 10 divided by 2 is a 5, right? So that is how you can think of. Clear? We have a conditional operator. So C supports a ternary operator pair like question mark and then colon, which is nothing but like a if else then kind of a case. But the expression says like this: expression 1, if expression 1, then expression 2, else expression 3. That is how I can read. So if you can have like a statement like if A greater than B, then written A, because this logical expression. if it is true, then A, else B. So in order you to write this in conditional operator, this is how you have to write, simple, right? If you look at an example here, this worked out problem demonstrated that A is equal to 10, B is equal to 25, then you have given as a conditional statement. How it evaluates is A greater than B, 10 greater than B. What does it means? This relationship gives a false, right? So if it is false, if this is true, then returns A, otherwise returns B. In our case, A greater than B is false. Because of this false, if block is not going to work, else block is what it returns. Else block means B is written. What is the value of B is 25, and hence this whole expression returns 25, right? So if you see the output, return value is 25. So instead of actually putting like this bigger a statement can be replaced into a single statement using conditional operator. C also supports special operators like a comma operator, size operator, a pointer operator, and then member selection operator. Okay, these are the operators. You may see them in upcoming sessions, but for quick review, how comma operator works. So you can see now A assigned to 10, B assigned to 15, and then compute A plus B, and then this value returns. In single statement, you can do this way. So it evaluates from the left to right. First it assigns 10 to A. Next it takes this, this one. It assigns 15 to B. Once these two are done, then goes to the third place. It computes the value of A and A plus B. The return of A plus B is what is going to be assigned to the value. The value which we written is now is 25 because 10 plus 15 is 25. Do you see? So in a single statement, I can get it. Otherwise, this becomes like what? A equal to 10, B is equal to 15, and then value equal to A plus B. That is how I have to write. Agree? One more special operator that we are going to discuss here is like a size of. What size of will do? Size of is actually returns how many bytes for that data type that the C allocates memory for us. So char means like a 1 byte, short means like a 2 bytes, things like that. If you can have this worked out problem, if you can compile the code and run it on your IDE, then this is how the output you could see. Okay, currently in my system, this is what the the dev C++ generated output for the C compiler, right? But using size of operator, you could also try out. So you may get like similar answer if the same platform. Otherwise, you may see a different answer. Depends upon what compiler that you're using. Thanks for watching. Please like, share, subscribe, click on bell icon, and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.